So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Oh, welcome to this week's Energy Show. Now, this week, we're talking about global warming again. Now, not just the future danger, but we're talking about the fact that extreme climate change has basically arrived. Now, it's kind of coincidence. We're actually recording the show this week. Here in San Jose, the temperature's been over 100 degrees. It's August. Now, it happens like that every once in a while. It just seems that these temperatures are more commonly getting hotter. So our team, a lot of our people, including me doing some work, we're suffering because the weather's really hot. But the climate has changed permanently, and it keeps getting worse. Now, some people don't believe that humans are the cause of global warming or climate change. And by the way, I call it global warming because that's what it is. It's not global cooling, it's global warming. Now, the Earth is indeed warming. That's a fact. 97% of climate scientists believe that this warming is caused by the CO2 in the atmosphere, and the CO2 comes from burning fossil fuels. And this warming is going to have severe consequences. We'll talk about that more in a few minutes. I'm not going to dwell on the debate. I understand that some people have some real good reasons why they don't believe that there is global warming, and they don't believe that it's caused by humans. But yeah, we got a pretty big problem. And if you're in a lot of the country, you're going to see that it's actually happening, and certainly also around the world. Now, first, a little bit of background, because people get confused between weather and climate. Weather is what you see outside on any particular day. For example, it might be 75 degrees and sunny, or it can be 20 degrees with heavy snow. So that's the weather. Climate is the average of the weather over a long period of time. For example, you can expect that it's going to snow in the Northeast in January, or in San Jose, it's going to be hot in August, September, and sometimes even in October. And it's going to be humid in the Southeast in July. So that's the climate. And when we talk about the climate changing, we're talking about changes in long-term averages of daily weather. Not just, it snowed a lot, or it's really cold in March, therefore we're not having climate change. Some idiot congressman brought a snowball into the House of Representatives saying, hey, look, it snowed. We don't have any global warming. That's baloney. So let's look at this phenomenon from a slightly different angle and a little bit more personal. There was a recent article in the Washington Post that many locations around the United States have already exceeded the 2-degree temperature rise that we're trying to prevent. The world was trying to prevent in the Paris Climate Change Accords. We're trying to prevent the worldwide temperature from going up by more than 1.5 degrees, and now it's 2 degrees, and, we have to act. So more about that in another show. So many locations around the United States are already over 2 degrees, including my hometown in New Jersey and much of Silicon Valley. So here's what the Washington Post study did. It's pretty simple. They analyzed more than a century of data from the National Oceanic and Atmospheric Administration. They have temperature data all around the country. So they measured that data, and they had 124 years of data. Couldn't go back 200 years or 300 years because we weren't really tracking that temperature that accurately. They looked at the lower 48 states and 3,100 different counties. And what they're finding is major areas around the country, and surprising areas, we'll talk about that more in a minute, are nearing or have already crossed the 2 degrees Celsius mark. So even though the worldwide temperature has gone up, I think, by less than a degree so far, a lot of places where people live, it's already gone up by more than 2 degrees. And heck, it's continuing to go up. This happened to be the hottest July ever recorded by mankind in the world. And we keep on breaking these bad records about really hot summers and about relatively warm winters. Now, there's a great illustration in the article, you can see it online, showing throughout the U.S. where the warming's the most severe. And more than 1 in 10 Americans, about 34 million people, are living in rapidly heating regions, including areas like New York City and Los Angeles. 71 counties around the country have already hit the 2 degrees Celsius mark. Now, also what's kind of interesting, but not really when you kind of look at what's causing this warming, Alaska is the fastest warming state in the country, but Rhode Island is the first state in the lower 48 states where the average temperature rise is over 2 degrees Celsius. And we'll talk about the reason why Alaska is the fastest warming is in almost all these locations, it's higher winter temperatures that have been very significant in terms of the warming. In other words, instead of the average winter temperature being 15 degrees, it might be 18 degrees Fahrenheit. It's easier for me to think in those fashions. And there's more significance there. So the winters are getting milder, and that's obviously the summers are getting warmer also. Now, when you look at the study, I kind of dug through it and trying to look at both sides as best as I can. A few areas in the country actually have temperatures that have actually declined on the average. Certain regions in Mississippi, Alabama, Oklahoma, Arkansas. Other than those areas, the entire country has warmed up, most significantly in the winter. Now, before we delve into more details of kind of what's happening here, you have to remember that this study only looked at temperature changes over the last 124 years, not the thousands of years or millions of years. Now, significantly, it's been over the last 100 years that we've really, really increased our usage of fossil fuels, even more significantly over the last 50 years. And there's other things that are happening in terms of fluorocarbons. In other words, the refrigerant that's used in home, office, and air conditioning systems. That also has an impact on global warming, other chemicals in the air, methane, things like that. So we're really just looking over the last 124 years. And the study's also not looking at the cause of the global warming. So there might be other factors that have a tendency to mean that these areas like New York and LA have increased. Now, one of the factors could be regional air pollution. Another factor, which is probably pretty likely, is urbanization. So cities are always warmer than the countryside. For one reason is there's not a lot of trees and grass. So you've got buildings that have a tendency to heat up. You also have buildings that are absorbing heat. And you also have a lot of combustion going on. The buildings are burning natural gas. There's a lot of cars and things like that. So literally, they're hotspots. And then just from a raw thermodynamic standpoint, any place that's using a lot of electricity, every bit of that electricity almost ends up as heat at some point. So when you have lots of power lines going into a place, that place is going to be warmer on the average because the electricity ends up turning into heat. All right. Now, the key significant factor of this study is that the warming is really hitting where we live. In my hometown in Essex County, New Jersey, the average temperature increase over the last, since 1895, was exactly 2.0 degrees Celsius. Now, when I go back home in New Jersey, the summers always seem hotter. And the winters definitely don't seem to be as cold. In other words, it's not cold from December to March as much anymore. But what's also really interesting is we've had a lot of really snowy winters. And we also have a lot of really wet summers. So what's happening is there's extreme weather events. And one of the reasons why we have these extreme weather events, usually the weather events involve snow or rain, is because as the air warms up, the air can hold more moisture. Actually, it's going to rain more. And even in the winter, when it's a little bit warmer, you're going to get more snow. So it might not be a really cold snowstorm. It might be a 28-degree snowstorm, but there's more moisture in the air. So you're getting more rain and snow. We're certainly seeing that pretty much all around the country. Now, just back to New Jersey, Lake Hopatcong, it's the state largest lake. I used to go ice fishing there when I was a kid in Boy Scouts. And what's also interesting is before refrigeration, Lake Hopatcong was where New York City and the New York City area got a lot of its refrigeration. Now, the way the refrigeration was done, they didn't have refrigerators, they didn't have coolants. Carrier hadn't figured that out yet. Basically, they mined the ice from freshwater lakes. So they carved the ice out of the lakes into big blocks that they were able to lift. They put them on horses. The horses carried them over to trains. They went in these ice car box cars, and they were shipped into the cities with insulation. And basically, that's how people kept things cold in their apartments, in their homes. They had literally ice boxes. It was a little metal box, little wood box, and insulation, and they would have ice deliveries. You get a block of ice delivered a few times a week. Now, what's happening with Lake Hopatcong, the winters aren't cold enough to freeze the ice solid over the lake. Sometimes you can't even go ice fishing there anymore. And also what's happening in the summer, the lake warms up so much that they have toxic algae blooms. When they have these toxic algae blooms, the lake has to close. So this is just a lake in New Jersey, right? Not a lot of people are going to care about this. But it's happening all around the United States also. In Los Angeles, the average temperature rise since 1895 was 2.3 degrees. Silicon Valley, average temperature rise was about 2 degrees. In New York City, the average temperature rise was 2.2 degrees. Now, it's not just happening in the urban areas. When you look at the map, it's also happening along the northern part of the United States. A lot of the states, Montana, Michigan, Idaho, they have areas pretty close up to Canada. Canada's cold, where the temperature has warmed up more than 2 degrees. Now, it's not like they're exceedingly hot summers like Phoenix experiences, but they're having milder winters. Okay. Bad stuff happens when the Earth heats up. Now, if it heats up a little bit, these bad things aren't going to be too bad. If it heats up a lot, it's going to be a disaster. It's just kind of looking at some of these things. What's going to happen is virtually all the world's coral reefs are going to die. It's just the water's going to be too warm. There's not going to be enough nutrients in the water for the coral to survive. And then you have the retreating ice sheets. So the ice sheets are going to melt in Greenland and Antarctica. And what's going to happen is that ice is right now above sea level. When that ice melts, you're going to get a massive sea level rise. And we're not talking about a few inches, and the sea level's already risen that much. We're talking about yards. And then there's the summertime Arctic ice. There's a lot of ice in the Arctic up north and also down in Antarctic. That's a shield against further warming, because what happens is ice reflects the sun, and so that sunlight goes back into space. Well, if there's no ice there, you're going to have water that's going to actually absorb it, and the ice is going to disappear even faster. And they do some measurements on the glaciers in the Arctic Sea, and those things are shrinking. Heck, went on a family vacation recently to the Athabasca Glacier up in Alberta. And it was daunting to see. It was scary how quickly that glacier had receded over the last 100 years. It receded 500 yards. And it just keeps shrinking and shrinking and shrinking. All right. So what's happening now is we're getting to the point where it's a tipping point. The classic scenario where things, they don't stabilize. They get worse really fast. I mean, tipping point, right? If you take something, you take a pencil and you put it on your desk and you hold it vertically, it's okay. Once it gets kind of slightly off vertical, it just tips over. Well, that's what's happening to the climate. We talked about how when there's a lot of ice in the Arctic, it reflects sunlight. When that ice melts, all that sunlight, the energy in the sun is going to be absorbed by the water. It's not going to be reflected, so the water is going to heat up. Land also absorbs sunlight. Where you have glaciers, where that sunlight used to hit the glacier, reflect up because it's white, now it's going to hit dark soil, which is going to warm up. And once again, as the ice melts, you get more heat that is absorbed by the Earth, and it accelerates it. As seawater warms, the seawater that's around the glaciers, that's around the ice sheets, is actually going to melt the ice even faster. And then you have another scenario where when water is cold, it holds more dissolved gases. So let's talk about two dissolved gases that are really important. One is CO2. And one is oxygen. So cold water holds more CO2, and cold water also holds more oxygen. Well, as the water gradually warms up, it releases more CO2 in the atmosphere. So the warming actually releases even more CO2 than we've been able to measure. But what's just as bad is there's less oxygen that can stay in the water. Guess what needs oxygen? Fish, nutrients, plankton, things like that. So when there's less oxygen in the water, there's fewer fish, there's less coral, and the reason why there's fewer fish is there's less food for the fish to eat. So the warming problem gets worse and worse, faster and faster. It tips, and that's kind of what we're trying to avoid. So, all right, what's the impact on our day-to-day lives, right? So heck, it's 100 degrees here in San Jose. It's not disastrous. It'll cool down at night. But when the Earth warms up, when the globe warms up, there's warmer water, there's less fish. So there's a lot of areas up in Canada, northern the U.S., or really around the globe, where there used to be a lot of fishing, and the fishing isn't as good anymore because basically the water has warmed up just a little bit, but there's fewer nutrients in the water. So yeah, it's kind of not intuitive. You think, there's fish, there'll be more fish where the water's warm. Well, that's kind of, people like warmer water, but fish like colder water because there's more nutrients and because there's more oxygen in the water. All right, sea level rise. That's probably going to be a tremendous impact for anybody on the coast over the next 100 years. When sea levels rise, the coastal cities are going to be underwater. They're going to have to move inland. Heck, it's hard enough, moving a house. Think about moving a building. It's talking about putting in dikes. They did a lot of dikes in the Netherlands, and seawalls and barriers against tides coming in. That's going to help a little bit, but it's only going to be a temporary fix. I mean, you look at kind of the city of New Orleans. It's basically underwater, and every year the water kind of gets a little bit higher and higher and higher. So yes, we're going to put in a lot of concrete dikes and a lot of concrete seawalls, but we're also going to have to start moving inland. The hot areas on the earth, I read another article about this, and people basically can't live when the temperature gets up to 130 degrees. These places in, around the Middle East and other parts around the world, they're over 130 degrees, and they're humid. They're not really dry. It's not like a desert. They're really humid. By the way, if it were a desert, there's no water, so there's really no way for people to live too effectively in a desert. It's too hot. You can't grow plants because there's no water, and you got to move. So the Sahara Desert is going to expand. There's deserts all around the world. So what's going to happen as it gets hotter where people are living now? They're going to have to migrate. People around the equator, where it's the hottest, they're going to have to migrate north or south. They're going to have to move where it's cooler. Agriculture is going to change. They're not going to be able to farm in these really hot areas anymore. There's not going to be enough water because it's arid, and there's also not going to be enough food. So people are going to have to move. Think about the mass migration of humanity. Now, that's an immediate impact on humans, where the society is going to have to move where it's more temperate. But species are going to go extinct. The habitats are going to change. One simple example, no more penguins. Where the penguins are going to go? I'd say some people don't really care that much about penguins, although my daughter is just crazy about it. But there's not going to be penguins around the Antarctic. They don't have anywhere else to go. The hotter climate. Also, what happens, we talk about this, the air holds more moisture when the air is warmer. So we get more hurricanes in the north and cyclones in the southern hemisphere. There's more rain, there's more snow. And these bad weather events also have probably a disproportionately bad impact on coastal areas, because that's where you have sea level rises. The sea level's higher when you have a big windstorm. It pushes a lot of water onto the land and wipes out a lot of buildings. All right, now, other little things, you don't think about it. Let's talk about a really little thing. More tropical pests. More mosquitoes. There's more moisture where people live. There's going to be more mosquitoes. By the way, you kind of read about what the most deadly creature is on Earth. You look at what's created the most deaths. Maybe it's a lion. Maybe it's a coyote. Maybe it's a rattlesnake. Maybe it's a bee. Well, it turns out that the most deadly animal is a mosquito, because it carries malaria, and malaria kills a lot of people. So as the weather warms up, we're going to have more mosquitoes. And what do you do about that? All right. So let's kind of take this closer to home. What about the impact in the San Francisco Bay Area? Now, obviously, it's going to be hotter, and it's more manageable. Since I've been living here for about the last 20 years or so, I've noticed that a lot more people are putting in air conditioning. They're retrofitting their homes with air conditioning. My house got retrofitted with air conditioning. They're putting in portable air conditioners. Every new home basically has air conditioning now, and when they were built 20, 30, 50, 75 years ago, they didn't. And heck, people are putting in more solar because it's more cost effective, and everybody's using more electricity. By the way, quick aside, people don't realize this, but solar electric panels actually work better when it's cool, not hot. Solar thermal panels like pool heating systems, the old solar domestic hot water systems, obviously that works better when it's hot. But solar panels are an electronic device, and when it's hotter, resistance goes up and they don't work as well. All right. Other impact on the San Francisco Bay Area is it's hotter. There's sometimes more rain in the winter. There's more brush, and we're going to get more wildfires. More wildfires because there's more housing where trees are. We're not perhaps doing as good a job to prune those trees, but it's a problem that's going to continue to get worse. Now, the biggest impact I think that's going to hit the Bay Area is sea level rise. The water around the bay is going to go up. Coastal developments are going to be underwater. We're already seeing this around the country. Hurricane Sandy in New York City. A lot of the equipment in basements of buildings that were kind of right near the water, it got flooded. The electrical rooms, the utility rooms, that are underwater. They had to replace a lot of equipment. So they got to make that resistant. Now, these things don't happen all at once. They're initially going to happen from really big storms where the floods are big, but then those storms are going to be more and more common. And you might see flooding not, once every 20 years, but once every 10, every 5 years. And then you're going to say, heck, we got to move. Got to get out of here. Highway 101. It's right along the coast. Highway 880. It's also, pretty much along the coast. Those highways are going to have to get relocated. I think about communities that have been built over the last 50 years. Basically all of Foster City is going to be underwater. What do you do? Coastal cliffs are going to collapse. We see that happening along the coast of California, even, around the coast of the Northern California, where the ocean's kind of chewing away at the hillsides, and that gradually collapses. I mean, Pacifica, it's happening, and all along the California coast. I kind of look at, there was another example recently along the East Coast. Buildings have to move inland. A friend of mine has a house in Narragansett Bay, and there in Narragansett Bay, the water level has been encroaching. The bay is pretty high, and the houses are all built on sand that's pretty close to the water. The water has been encroaching at the rate, I believe this is 3.3 feet per year. So the houses that used to be right on the water, they had to get moved. And, where are you going to move? You're going to move like 100 yards back? Well, somebody else is already living there. So it's really a problem. So what do we do as a society? Well, the first thing we have to do is acknowledge the problem. And many of us, most of us, 97% of scientists say the problem is there. The most important thing we have to do is we have to act. And, the United States and the rest of the world is acting. The United States stepped away from the Paris Climate Accords, incredibly stupid thing to do. The rest of the world is acting. But we have to act really fast and really significantly. And the biggest economy in the world has basically said it's not a problem. There's an interesting book called The Carbon Drawdown Project. And that kind of talks about the things that we can do most effectively to reduce these global warming problems. So some of the things that will work: eliminating the consumption of fossil fuels. That's going to slow down CO2. You generating all of our energy from clean energy like wind, solar, hydro. Changing the way we do agriculture, actually moving towards more of a plant-based diet, because animal diet actually, there's lots of reasons why that generates more CO2. We're going to have to change our land use. We need more trees that are going to absorb carbon dioxide. And we're also going to have to change our transportation. Now, there's things that we talk about that might work, like carbon sequestration. The problem is, thermodynamically, that's really, really hard to do. It's hard to kind of take carbon out of a fossil fuel. You're burning it to generate energy, and that it takes energy to put it back in. So you end up with expensive energy. And it's going to take forever. There's not really any carbon sequestration technology that's really scaled up. Really, the best way to do that is really just plant a lot of trees. And, that's tough because humanity's still cutting down trees to make room for more farming. So there are things we can do. I think the most significant thing is within the U.S., support some kind of activity towards climate change and get back into the Paris Climate Accords. All right. That's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you miss any of today's show, you can go to our website at cinnamon.energy and listen to the podcast.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.